Hi there, welcome again to Distributed SQL Summit 2022. In this session, we're going to talk about Voyager, which is a new data migration tool from Yugabyte. And also to get a feel for how it works, we're going to go through a demo, migrate a schema from Oracle to Yugabyte so you can see what it looks like. I'm Michael Lass, I'm part of the technical pre-sales team, and joining me is Prasad, who's on the product team.
Okay, let's jump right into it. Voyager to me is a product more than just a tool, and you'll see why as we walk through the slides and then the demo at the end. It's a very fascinating product for a very simple reason that it solves a problem that's very common and popular out there, yet it's not comprehensively solved. So let's start with the motivation. What's the motivation? Why did we go about creating Voyager? So now, the enterprises, the customers that we deal with, often they are into a modernization effort to modernize some of their legacy apps that have been powering their business applications over to modern cloud native apps. Right now, the legacy apps, obviously, over time, the TCO it has gone much higher, and it doesn't scale to the newer business needs and requirements. Performance over time has degraded. And so on, right? So then that gives sort of the reason to modernize, and as they modernize more towards a microservices model or the cloud native apps, as how it's called, then you get to tap into cloud and containers and so on, and lower configurable TCO. The benefits are quite a bit on the other end as you modernize, right? Now that said, this modernization effort of doesn't quite attain a state of completion until you can figure out what to do with your data, right? Because the analogous or the equivalent part on the other side is going to be your transactional databases, typically the likes of Oracle and DB2 that's out there. So it's expensive licensing model, proprietary technology. It's not based on open source, doesn't scale, it's not distributed. And even if it is based on Postgres or MySQL, that's it's tied to a cloud provider oftentimes, and doesn't meet evolving security and compliance needs, and so on. Now, one of the popular choices out there, obviously, selfishly, is going to be Yugabyte, to modernize your data stack for the cloud native apps. And the benefits on the Yugabyte side, although we are not going to focus much on that, just to highlight the key ones out there, based on open source, Apache 2.0 license. It's a cloud native database, brings distributed SQL, lower TCO, scales horizontally and vertically beautifully, brings better, higher performance, and most importantly, it's Postgres compatible. So it's a familiar, known sort of an API or interface for developers as they develop their apps. It's just plain old Postgres on the query layer and distributed down underneath, plus a bunch of other benefits. Right now, often this modernization effort includes migration. So you will have to migrate, your legacy databases, its schema, and so on over to Yugabyte, right? So now, what are the options that are out there, right? So modernization, when it comes to the database layer, almost always involves migration, right? So now let's keep the focus on migration. Let's look at what are some of the challenges when it comes to migrating from a legacy database over to a modern cloud native database like Yugabyte. Right? So typically migration, it's not rocket science. There is a source database, there is a target database. And typically you would use a migration tool so that would take care of, taking the schema from the source and then translating it or modifying it as needed and applying it on the target database technology, whatever that might be, and then exports the data files and ingest the data. And some of the migration tools out there can even do change data capture, as in if the source database is still live and active, it can capture all the live changes and keep applying it over to the target database until they are ready to switch over all traffic over to the new target database, right? Now, when it comes to distributed SQL, especially for a database like Yugabyte, where it's a distributed data store, most of these migration tools are they don't work well. Now, the reason being that, they were developed, now they work really well when the target database is again a monolithic or single node database like MySQL or Postgres, right? Now, the other scenario is these migration tools are unaware of the strengths of a distributed database, because it doesn't scale by itself. For instance, if there are like 100 cores or 200 cores or like 20 nodes available on the target database, it doesn't quite understand, now can I spin, now more connections, or can I ingest at a faster pace? How do I go in parallel? So, that sort of an intelligence usually is not baked into the migration tool. And some tools depend on computational cluster. For instance, you might need to write a MapReduce job or a Spark job to be able to, generate SS tables or whatnot, and then do parallel ingestion. So that creates dependency to have, some cluster like Spark or Hadoop available to get the data load done over to the distributed database. So taking all this, sort of limitations and, take into consideration, we wanted to figure out, what's now the requirement if we want to build a product, to help ease this migration modernization pain for the database layer. What would be the requirements for such a product, right? So start simple, like, there are obviously, two modes, like, you want to do offline migration, as in, you cut all the traffic to the source and you are able to very cleanly migrate from there over to Yugabyte. The online migration is the whole, scenario where there is still traffic coming in and you are yet able to do the migration over to Yugabyte. And we also wanted to have a failback option, as in during the migration process, if there is any, hiccups, or if there are any challenges, if you want to switch back to your existing database, how would you do a failback? So these are like, sort of three major blocks or three major, buckets of requirements. And to expand on that, offline migration, we saw sort of the process flow earlier, pretty much sticks to it, as in we want to be able to connect to the source or the legacy database, export the schema, export the objects, or and then export data, and then, apply it on the target Yugabyte database and do some good stuff like validation and so on. And on the online migration mode, everything, and additionally, to be able to do change data capture and apply it on Yugabyte. Failback, I explained it already. But it's not, just these three. We also had a bunch of other things, that we wanted to factor in. For instance, we wanted to have a user-friendly CLI, so it's a lot easier even to automate on top of the CLI, to be able to chunk the source files into, smaller bits, as in if there are some transactional tables that have billions of rows, to be able to chunk it to, let's say, 10,000 or 100,000 rows, or smaller files, so we could ingest in parallel. And then, to be able to connect with popular databases out there like Oracle, SQL Server, and MySQL, and to be able to do the seamless migration. And most importantly, we wanted to have the same user experience regardless of what is the source database. May it be flat files, Oracle, MySQL. Can the user experience be normalized or standardized in a way that it looks the same with regards to how this product is used for the migration effort? And some of safe defaults we want to introduce, as in if there is a 3-node Yugabyte on the target side versus a 10-node Yugabyte cluster, to be able to dynamically figure out, now like what is the right number of connections, what should be the right batch size depending on the cluster configuration on Yugabyte side, disabling transaction mode, enabling upset mode. Those are the safe defaults. Of course, you could override it. And item potency is again key when it comes to data migration or data loading, as in the same file, if I'm pushing it twice, it shouldn't result in duplicates on the target Yugabyte side. So these were some of the key additional requirements that we took along with offline, online, and the failback modes, right? Now I'll walk you through the offline migration. One thing to highlight here is right now the product has offline migration available. Online and failback are sort of in the roadmap or work in progress, and it will be available, very soon.
Yes, I just wanted to mention that, I love that the failback options on the roadmap. Cutover for customers can be really scary, especially if it's an all or nothing migration. So just being able to fail back to your legacy DB, if necessary, not skip a beat, your data is all synced. It's a very valuable tool that would give a lot of peace of mind. The other thing, just from a DBA, I have kind of a DBA background, speaking from that point of view, what really stands out to me, the features of Voyager, the fact that it can automatically break up the data files and automatically run, things in parallel, taking advantage of all the nodes of your cluster. Also, the fact that it will convert your DDL to Yugabyte friendly syntax, that can be a very manual, tedious process without a tool like this. So just wanted to make those points.
Good points. On the failback mode, one other, Mike, I think you would have seen this, more number of times. You are customer facing on daily basis, is that this migration effort is not just about the data layer, right? So a lot of times when the apps are being cut over to the, cutting the traffic over to cloud, if there are any, issues there, usually the apps would be the first ones to fail back. And when they fail back, you would want the database to also fail back, or the data layer to also fail back. So having this option is useful, for multiple scenarios that we have seen so far with customers. So now I'll, do a quick walkthrough of the offline migration process flow in Voyager. So phase one is the prepare phase, where it is, simple enough. You're installing Voyager because it's a product. You would install it in a VM, and you just want to ensure that the VM has sufficient, disk space, because we would be exporting data from the source database and keeping it in the local file system to Voyager for a little while until it's fully migrated over to Yugabyte. And it goes without saying, verifying connectivity and right level of access with the source database and also with target Yugabyte database are all part of the prepare phase. Now, the next phase is, migrating schema. So in this phase, simply, one can use the CLI to, kickstart, and we would export all the schema objects like tables, views, stored procedures, functions, and whatnot. And we would also translate that to Postgres compatible syntax. Now, there is an optional step in this phase where it is for the user to manually inspect, verify, and make tweaks to the DDLs if necessary. Right? Now, this could be the classic scenario where your legacy database was not distributed in nature, but Yugabyte is. So if you want to figure out in a different way to shard the data or other indexes that you might want to remove or add, so those things can be, this would be the phase where, you would make necessary modifications as needed. And then the import schema is the step where whatever was exported and analyzed is now set to be applied on the target Yugabyte database. Now, some of the safe defaults here, again, you could override, is that we would disable indexes as in they're deferred, and that would get created after the data load. Foreign key check is disabled because this is a bulk load. So the data load happens at a faster pace if, foreign key is disabled, and triggers are created but kept disabled. I think there are a few more safe defaults, but the key ones are highlighted here. Phase 3 is migrating the data. Now, what we have done so far is the prep, and then we have migrated the schema. And in this phase, we would migrate the data. So you have the empty structure created on the Yugabyte side. Now, in this phase, what we would do is we would connect back with the source database, and we would export data per table to flat files. Now, these flat files, we will again, internally, we would chunk it to 100K rows per file as a safe default. You could tweak it if you think that's the right thing to do. And these chunks are, again, named appropriately. There is some metadata around it, so we know which file is being processed and so on. That is all internal to Voyager, but it's all, handled out of the box. And then what we do is, with regards to the next phase, which is import data, we would make one connection per data node. So if it's a 10-node cluster, we would spawn 10 connections. However, again, that's a very safe default, I want to say, because usually you can fire hundreds of connections at Yugabyte very easily. So you could go tweak it. So you have that many connections and you get that many parallel threads of data ingestion that would happen. Now, each file, which is kept at 100K chunk, 100K rows, is loaded, or each file is bulk loaded, and then Voyager tracks the progress within each file and across all such files and all the tables. And if there are any failures in a large data migration project, usually there's going to be, it's not unusual that you would see some failures, right? Now, it could be because there is an invalid character set or, some issues like that where you would need to intervene. And in that case, Voyager is smart enough to resume from where it left off and not restart the whole, data migration process. And then as a last step, there is a verification, as in, hey, I had 10 million rows on this table on the source database. Did all 10 million get to the target database on target table on Yugabyte? So that's the verification phase, and that's kind of concludes the migration from legacy database over to Yugabyte. All right, on to the demo now. So Mike.
Yeah, so we're going to do a demo of Voyager, so you can see it in action. We're going to be migrating a schema, some data from Oracle to Yugabyte. To set up this demo, I had to set up 3 components in my Oracle database, my client on EC2, and my Yugabyte database. Yeah, so on the source side, it's an Oracle database. I just spun that up in AWS RDS. It's pretty easy to do that from AWS. If we take a look at that, I've also got dbeaver running, so I've got connections to both the Oracle database and a Yugabyte. And on the Oracle side, I loaded up Northwind. It's kind of a pretty popular demo database. Just got that off GitHub, and so we got some representative tables here to make it interesting. Since we're coming from Oracle, I created a view. We've got about 20 indexes. We've got some sequences, since those are pretty popular in Oracle, and then a stored procedure, because that's usually a main concern of people migrating off of Oracle. As for the size, I want to make the sizes, make this thing work a little bit, but I didn't want it to take a really long time for the demo. So just to give you an idea, the 2 biggest tables are orders and order details. So if we do a select count from those, we've got 849,000 rows and orders, and about 2.2 million in order details. So nice. That's what we're going to be migrating.
Okay.
And then as far as our Yugabyte database, I spun that up. It's on AWS also, using our Yugabyte Anywhere platform. It's 3 nodes, version 2.15.1. Let's see the 3 nodes. We're in 3 different availability zones, all in the East 1 region. And like I said, the Voyager client's just a VM on EC2. I set up also in the East region. So that's kind of a setup. And so heading over to my sessions here. So what I did, just to make it easy, there's 5 steps. I scripted them all out with little wrapper scripts, 1 through 5. The first thing we're going to do, one thing I had to do to make this work well is in my bash profile, I've got my environment variable set that all the scripts can reuse. So I've got things like database name, port, user, passwords, those kind of things. And then to level set too, just to speed up the demo. The Voyager's already installed. I've already got the users and roles and everything, all the prep work you would do. So we're just going to kind of jump right to the data migration part. And the first step of data migration is exporting the schema. So we'll take a look at what that looks like. This is going to convert our Oracle schema to Postgres. It's basically just a CLI call, DB Voyager export schema, pass it the variables. I'm running start clean, using the start clean option so that it will remove any previous work I've done. So we'll go ahead and run that. It's just going to confirm I want to blow away what I've already done. So we're going to export all the different objects, type sequences, tables, our procedure, our views, everything from our Oracle version 19c database. Okay, so that's done, and it will create all these little DDL files and our export directory in the schema directory under that. So next is the analyze steps. We're going to analyze the schema. It's going to look for anything, make any recommendations of things we should change in our DDL. This gives you a good opportunity if you want to tweak your DDL, for a distributed SQL database like Yugabyte. This runs really quick. It just generates a report for us. We'll take a look at the report. Okay, if we start from the top here, it's going to go through all the different objects. We want to see a valid count, the same as our total count. So sequences look good, 7 total, 7 valid. Tables, 8 for 8. Indexes, 2020. Views are good, procedures are good. Synonyms are good. And then we hit this one error. And the reason I'm hitting this error is because this Oracle database is running in Amazon RDS, and they have a special view they create in there. We don't really need it for our purposes, but it kind of gives you a good example how to edit things. So we're going to fix that problem. We can just, gives you the exact file that's the problem, which is the synonym.sql file. We'll edit that. And again, these statements are really only needed inside our Amazon, for Amazon purposes, so we can get rid of them. We'll delete those. And now we can rerun our analyze, and it should come up clean now. Check our report. Okay, yeah, we're all good, we're clean. So at this point, we're saying, yes, our DDL is good. We like the way it looks, and as being a DBA, this saved you a lot of work. Like, it's very tedious to go through maybe hundreds of tables to try to convert those from one database to another. So this is a big time saver here. The next step we have is now we're going to export our data from Oracle into flat files. We'll take a look at that. Very similar. It's a very consistent command line interface. Just DB Voyager, export data, pass it your options. Go ahead and kick that off. And it's figured out, we've got 8 tables to export. It creates the list of tables, starts going through them one by one. The orders and order details tables are a little bigger, so you're going to see your progress bar going along there, like we're almost 40% on orders. So it's going to chug through those. And again, this Voyager is going out to your Oracle database and pulling all that data onto the Voyager client. Almost done with orders, okay. And order details is the other large table. You can see the progress. Okay, we're finishing up those last few small tables. And at the end of export data, it gives you, kind of a summary, each table, how many rows that came in. And we've got exported data complete, nice green check. So at this point, we're ready to move on. We've got all our flat files ready. The next step is import schema, and this is going to pre-create all the Yugabyte database objects. No data yet. That'll be the next step. So if we take a look at import schema, we can go ahead and run it. It's going to confirm I want to drop the schema I already have. So now it's creating all our Yugabyte objects. Okay, so that's done. So at this point, we should have our tables and objects in Yugabyte, but they should be empty. One thing we can do, we can go to the Yugabyte platform. We can go to tables. We should see a list of our tables. You see like orders, order details, but size is 0. There's no data there yet. We can confirm that in dbeaver. If I switch my input to Yugabyte, rerun these queries, we should get 0 rows. 0 for order details and 0 for orders. So as we would expect. And then the final step, and now we're going to import the data. There's a couple options I want to point out. As Prasad talked about them during the slide deck. So some things you can tweak when you're importing the data, because this will typically be, perhaps the most time-consuming part, right? You want to take advantage of the number of nodes in your cluster or parallelism. So you can tweak this parallel jobs parameter. I have it set to -1, which is the default, which would be 1 connection per database node, but you can adjust that, based on how much CPU you have available. And then the batch size right now is set to 100,000 records. That's how big of chunks it chunks things into. You can play around with that and hopefully optimize your import time. So we'll go ahead and kick that off. And first thing is doing is truncating all the tables and thinning them out in case I had some data. And then similar to when you export it from Oracle, as it's importing the larger tables, you're going to see a progress bar. So it gives you some feel for how much time you have left. Okay, so at this point, all the tables are imported, as you can see by the green message here. The next step is it's going to create all the indexes. It deferred doing that till later to make the load faster, so that's going to take a few minutes. So while we're waiting for that, one thing we can do is verify a couple things like our row counts. So if we go back over to dbeaver as Yugabyte, now these row counts, we'd expect them to be the same thing we saw in Oracle. We'll select count star from orders. And indeed, we've got a little over 800,000. For details, we should be seeing about 2.2 million. So that looks good. Another thing we can check is, I told you about we created a view. We can just verify that we can select from our view and that we can run our stored procedure. So I'm going to log into Yugabyte here, into my Voyager demo database, and just do a simple select star from this view just to verify it, validate it. Okay, so that looks good. The view works. And then we created this procedure. This Oracle stored procedure. It's just called update employee title, and you just pass an employee ID and what the title of the employee is. So what we can do is let's see what our employees look like right now. Employee 1 is a developer. So why don't we call our storage procedure, but we'll give this employee a little promotion to DBA. Inside joke to all the DBAs out there. So we'll run the stored procedure, and then let's verify it actually updated the title. So good deal. Our stored procedure works as expected. So that's a plus. I mean, and the reality is, it's going to take, for more complicated stored procedures, it's probably going to get you 80, 90% there. There may be some, manual tweaks that are required for that. Our indexes are still creating. All
All
right,
right.
so our index is
All
finished.
right.
All the tables are imported successfully. And you can
Nice.
see from the timestamps, it would take about 8 minutes to import 3 million rows. Not too bad for that small cluster. So that really concludes our demo. I hope this gave you kind of a feel for Voyager, what it can do. And the next time you need to migrate, think about migrating a database to Yugabyte, that you check out Voyager before you try to do this manually. But thanks again for your time, everybody.